Good morning, everyone. My name is Anna. I will be your moderator today. I will go over a few logistic items, and then we will introduce Andrew, and we will go ahead and get started with the presentations. As you're viewing the presentation, you can also chat privately with me, or if you have any question, you can enter into the question queue. In addition to the presentation, we also have a couple attachments. One is a big data visibility brochure for you to learn more, and also an infographic that you can download at any time. A copy of the presentation will be provided to you via email after the presentations. And of course, you can also ask us any question during or the presentations or during the 15-minute Q&A session at the end. No further ado, allow me to introduce our presenter today, Andrew Harding. Andrew, would you like to go ahead and introduce yourself?
Sure. I'm Andrew Harding. I'm Vice President of Product Management here at VSS Monitoring. Today we're going to do more than look at a bunch of words on a slide. We're going to do the first of a two-part series on big data and its use in the IT domain and what we mean by that. We're really going to be describing a shift in the network monitoring landscape and kind of the why and the what around what we call big data visibility. And part two, next week, we'll get more into the how and really concrete technical next steps. So this shift that we're seeing in the network monitoring landscape, this evolving of this evolution of architectures, it's similar to what happened with the emergence of software-defined networking, but on the monitoring side. The emergence of a visibility plane or a monitoring fabric was really the first stage. Such a visibility plane provides a true copy of traffic to performance monitoring tools and to security systems. And this visibility plane does that without the limitations of span and monitoring. A visibility plane can be used for passive traffic with the right design. It can also be used on active traffic. So we can operate on that true copy of traffic or on active production network traffic, mostly in security environments. This same visibility plane can enable organizations to leverage, a big data model to increase the scalability and efficiency of their monitoring, their security, their network forensics deployments. Those same optimizations that enable performance monitoring tools to be centralized can be extended to help organizations leverage a big data model within network engineering or security operations. Before I get too much more into big data, I should probably explain what we mean by this big data model. Really what's kind of driving this change as we see it, what we're seeing in large-scale networks and enterprise networks. If you look at traditional solutions, they're locked into a vertically integrated design. This is sort of an artifact of legacy systems, the appliance-only mindset, the integrated appliance-only mindset. This traditional model can now be supplemented with a new model in which hardware and software and all the related data, the network data, can be decoupled and decoupled in an open fashion. And I'll walk through a bunch of those buzzwords as we talk here more. We've seen this pattern elsewhere in information technology, where decoupling is the method that people use to scale out systems. The decoupling and the systems that support that decoupling of these vertically integrated systems, they're really what's driving the adoption of a centralized packet capture model that enables both centralized processing and decentralized analysis from a single system. And that's really what we're terming the visibility plane. In the context of network monitoring and security, big data visibility enables open access to network data, breaking down that old model and allowing network data to be consumed. One of the big data terms is ingested, but to be consumed by a wide range of tools. That enables that network data to be used in both the synchronous real-time fashion and in the asynchronous or the batch model for use for offline processing. So by separating the data, the network data from the systems, and by separating the use of that data from time and doing more than streaming packets, we can enable new processing models and enable technical staff and budgets to scale to the demands of modern networks. So next I'm going to jump to a slide here that describes a bit about what we mean by scale. There's lots of buzzwords about or statistics about how server workloads are exploding, how data growth is exploding by large multiples, and how we're generating more and more data. Only a tiny percentage of that data ever gets analyzed anywhere outside of the very sort of tactical operational tools. The only way to accommodate this data is to adopt a big data approach, a decentralized model, and a model that doesn't rely on a single place processing a stream of packets. The volume of data that flows across these networks has continued to grow at just huge rates. And the virtualization infrastructure, all those virtual servers, driving compute costs down, makes spinning up a workload that's going to generate more traffic nearly automatic in some cases. So the cost of producing traffic is going towards zero, but the cost of managing and securing networks is increasing. The networks that carry this traffic are increasingly expensive to deploy and manage. So the volume of data is greater. The variety of data and the expectation of how we manage the delivery of that data is increasing. And we're now migrating to much faster networks, to 40 gig networks, to 100 gig networks, more traffic, and a variety of traffic, and speeds we've not had to manage before. These changes really require a new approach. So the goal here, what we're describing with sort of what we can do, is to adopt a new approach that enables us to scale performance management and security forensics beyond the traditional synchronous delivering a stream approach and use a single store of data for more than one application. That's really the key to the big data approach. That's really what enables data to be used in new ways. So by decoupling network data from tools and delivering it to tools and to other systems, in addition to making security and performance management more efficient, we can also find new uses for the data once it's decoupled from the operation systems. So here we show sort of the traditional system. I don't show the visibility plane or the network packet brokers on this slide. They're hidden in our blue arrows there. Traditional systems, whether they're physical systems or virtual hosts, look like the diagram here. On the left, the hosts are generating traffic. There's getting the traffic from a physical host. There's challenges and a different approach required to get traffic from a virtual host. It's typically delivered to vertically integrated tools. The visibility plane, the network taps, the packet brokers, they capture, aggregate, filter, optimize, and deliver the traffic to those systems, to security tools, to monitoring tools, which are here shown on the right. This approach locks the data within those systems. The storage of network traffic is tightly coupled with the security or the network management or even an analytics application, and those tools will process the data in a proprietary format usually. There are usually multiple types of tools deployed across the same piece of the network. Each of these tools are providing a specific function, and the application monitoring or security systems, they lock up the data, and if you're doing continuous monitoring on your network, you're doing recording on your network, that data is often just a small slice and locked away within your recording device. Some of the applications might be only acting on a piece of network traffic, maybe RTP frames for media streams, or maybe you're looking at specific outbound HTTP requests that match certain criteria. But there's often a very significant overlap of traffic that's directed to these tools. And identical network traffic is often replicated across multiple tool sets. And because each of these tools can only store a narrow slice at any given time, visibility is significantly limited. So the size of storage requirements as we see the increase in network traffic, as networks go to greater speeds, and the constraints have the unfortunate result of increasing the amount of stored network data without also increasing the scope of its application. This is a real problem because costs go up and there's no additional benefit. Apart from the high cost of storing data in a dedicated appliance, there are a number of issues that the current architecture really reveals. The data is tied to specific groups, to maybe the operations group or the security group. So we have incomplete, or kind of the jargon is siloed views across organizations, or inability to see it across organizations. Visibility is then fragmented. The data is not managed by the network owners. It's really tied tightly to the application and stored in a proprietary format, so it can't be accessed for any other use, though it's being stored away. The organization captures and stores the data, but there's no benefit beyond that one application. Scalability is also a challenge, because the only way to keep up with the increase in traffic and the growing number of applications and the increase in speed is to add more boxes. Over time, this becomes unworkable. All those purchases add up, increasing the demand on capital budgets, and operating all those appliances proves expensive over time. With each purchase, moving to a different tool, adding a new tool becomes more difficult, and the organization becomes less agile. You can't sort of be as quick to adopt something new. So organizations need to cost-effectively scale the storage of network data and accommodate new applications, forensics or compliance applications, while maintaining flexible control over that data.